Just in previous lecture, we got the idea what is mean points and what is epsilon. Now, let's see what is core point, what is border point, and what is noise point. Let's see. So, let's suppose let the data set we have D like that. These are the data set in our that we have. Already we got the concept of what is mean points. Already we have learned this concept. What is epsilon? Already we have learned it. Now let's discuss first one by one. First, let's discuss the what is core point. Let's see what is core points. Okay, the core point is the definition of the core point is if a point P has the at least minimum number of points in and some epsilon, then we call this point as a core point. So let's see one. So if a point P, if a point P has greater than equals to mean points of point, has greater than mean points of point in an epsilon, in an APS, means in an APS radius. These are the two hyperparameters, mean point and epsilon. Already we have learned this concept in previous lecture. So if a point P has greater than equal number of points in an epsilon radius, around it, if this have, then we call this point P is a core point. Now let's try to understand these things through a picture. So let's take we call our mean points. First, let's define the mean points. Let the mean points, we defined it, mean point is equals to 5, and epsilon, let define epsilon is equals to here 1.0. We defined it as on this example. So the point that P, so first we have to define the on this point. Suppose let's take here have some point P. This is the point P, and around this point we make the epsilon. This one the epsilon. This is the epsilon. Equals to, here we have taken here 1.0 that we have taken here. The simple one that we have taken here. This is the simple epsilon. Okay, let's now mean point we have defined here P. If the number of points in that region is greater than equals to 5, then we call this point with P will be a core point. So suppose let the number of points on these regions have this 1, 2, 3, 4, 5, 6. So how much point here we have? We got 1, 2, 3, 4, 5, 6, 7. So total number of point here we have 7. So in that regions, now in that region, number of points here is what? 1, 2, 3, 4, 5, 6, 7, 8. Number of points is equals to 8. Which one is greater than mean points? Mean points of P. Because here we have defined our mean point value is 5. So is greater than equals to mean point of P. So now we call that. This P is now, because of this E is called a core point. Now P is called a core point. Core point. Okay, because of this. Because of these reasons. So the simple idea behind the core point is if a point h greater than equal number of mean points of point in some epsilon radius around it, then we call these are the then this point we call it is a core point. I think you got the idea. So these are the hyperparameter. Parameter. Already we have learned this concept. So I think you got the answer when we discuss through an examples. I think then it will be more better. So now next concept is border point. What is border point? Let's see. Border point. Suppose let's I am taking the same point P. Border point. Those are the for making a border point. This point will be a border point if this point satisfies two conditions. So let's see one by one. So if this point satisfies two conditions, the first condition that it has to satisfy P is first condition is P is not a core point. Okay, the first condition that is P is not a core point. P is not a core point. This is the first condition. Okay, now the second condition is P must be belongs to neighborhood of Q. Wait, let's first try to understand. If this is not a core point, that means what? If this is not a core point, that means the P H less than number of points in mean point less than mean points of points in epsilon radius that means that's the first condition. And the second conditions that have P must be belongs to the neighborhood of some point Q, and Q is a core point. Some must be some neighborhood of some point Q where Q is a core point, where Q is a core point. Okay, I think you got the point. If Q is a core point, then and if the P lies on the neighborhood of that core point, then this P is called a border point. Okay, that's the first condition. First condition is P must not be a core point. Second condition P must be a lie on some neighborhood of a core point. This is the second condition. Okay, so what is the neighborhood? Now the concept, that is the questions that's come into our mind. What is this neighborhood? What is the neighborhood of P? Q. So neighborhood of Q, the point P is called the neighborhood of Q when the distance between P and Q, less than equals to this epsilon value. This epsilon. Keep this. So we will see these things through an examples. Okay? So we will see these things, what it actually means, these things. So first, suppose let's this our the region that we have. On that region, somewhere P is here, somewhere Q is here. Suppose Q is here, and the Q that we have is a core point. Let this is a core point. Okay, and somewhere q is here, somewhere here, p is here, somewhere here, somewhere here. This is the p that we have. Okay, now you and some regions also here, they have some region, they are on the basis of it, they have some region. Okay, they have some region on the basis of this point also. But the question is the mean number of points. Suppose let's take let the minimum number of points we have taken here 5. So let the mean points here, mean points is equals to 5 and epsilon EPS. We denoted through this symbol epsilon is equals to 1.0. So epsilon here we have taken 1. So I have to take this is a same kind of, and using same kind of. Okay, let this is the epsilon distance, let this is the epsilon 1, this distance is, suppose let this distance is, this is also epsilon distance 1. But the number of points on this region, I am using the color pink color. To the same color means I am using this orange color here to denote the number of points in the on that region, Q region. Suppose the number of point here we have is most point. How much point we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So based on this region, based on the Q regions, we have 11 points. So here on that regions we have number of points on these regions we have 11, and which is greater than the mean points. Mean points. Okay, so because of that Q is our core point. Now let's see on that regions, on that wide regions, on these wide regions how much point we have. In these white regions only we have 4 points, 1, 2, 3 on these regions. On this white region, in this white region we have, I'm using here the yellow color. On this white regions we have number of points is equals to 4, which is less than mean points, which is less than mean points. Okay, so since the number of points on this white region has the less point of the minimum points of point, because of this it is not a core point. So because of these reasons it is not a core point. Because of these reasons it is not a core point. Okay, I think you have got the idea. Now the questions that occur here are what is the neighborhood of the Q. So how P is the what is the relations between the neighborhood of P and Q. So now what we have to find the distances between them. So just find the distances between them. These are the distances between P and Q. Just see this. So here to here is the epsilon distance from here to here, but the distance between them is less than epsilon. Here this one, just I am using here to denote the pink color. See the pink color here now. These are the distance between P and Q, and this distance is obviously it is less than epsilon. Obviously it is less than epsilon. Sure. Now, because of these regions, we call it P belongs to some neighborhood of Q. Any I, sorry for that. Any I GHBOR neighborhood of Q. Because of these regions, we call P is lie on the regions of the Q. Okay, I think you got the idea from these examples why P is called the neighborhood of Q. Okay, so now let's discuss what is noise point. It is trivial. If you understand the core point and border point, then to understand the definitions of the noise point, it's trivial. So the noise point is called the noise point. You call this noise point. Noise point, it is a neither core point nor a border point. Means if a point is neither a core point or a border point, then we call this is a noise point. So if a point neither a core point nor a border point, then this point is called the noise point. First conditions is neither not point. The second condition is nor a border point. Then this point is called the noise point. Okay, I think from these discussions you got the idea what is core point, what is border point, and what is noise point. Now let's try to understand these things through a more concrete example, through a picture. I think it will be more visualizable. Okay, let's see. Now let's try to understand these three concepts, means core point, border point, and noise point through this picture. So here just first consider this point. Consider this point. Suppose this is the P1. Okay, and first consider this point. Now this is the core point, and here we have taken here the epsilon. The epsilon that we have taken here is equals to 1, and the mean points that we have considered here, the 4. Okay, so just see this picture first. So in P1 point, the what is the mean points around that? Means if you just draw the epsilon from this picture to this picture, just first find the epsilon. This is the epsilon 1. On this range of on the range of this epsilon radius, how much point we have? 1, 2. How much point we have? 1, 2. We just zoom it a little bit. I think it's better now. 1, 2, 3, 4, 5, 6. Total how much point we have on these regions? On these means I am talking about this pink region. I am just talking about this pink region. The number of points in this region, the number of points is equals to what? 1, 2, 3, 4, 5, 6, and once more here also 6, 7, which is greater than the mean points, So as our definition, P1 is called a core point. Because of these regions, P1 is a core point. Okay, because of this region, P1 is called a core point. Now let's the deep green color. Now let's see the deep green color to understand the border point that we have taken here. This region, which is the P2. Let's call this is the P2. Now based on the epsilon radius, so first, what is the definitions of the border point? Let's see it first. What is the definitions? P is not a core point. First condition, P must be lie on some neighborhood of some core point. P is not a core point and P must lie on some neighborhood of some core point. So this is the conditions. Now let's try to understand the P2 point. So P2 point, first I'm make the radius using the epsilon, just deep green color I have used here to denote it. This is the epsilon 1. I'm using here the green color to denote this circle around this epsilon radius. This is the circle. This is the circle. Okay, this is the circle. Now let's find what is the number of points on these regions. The number of points on this region is 1, 2, 3, 4. Only 4 point we have. Okay, only 4 point. Okay, so the number of points here is equals to 4, and our mean points is also equals to 4, equals to mean points. So mean points, because of these regions we call it is a border point. So now you can call, sir, if we taken the greater than is equals to less than equals to sign, just see this border point. If P has less than number of mean point, less than, so it is not, it's single point, it's not a matter. If it is a single point, it does not matter. So that's depend on author to author. So the examples actually I have taken these examples from the Google image. So the authors that the examples make, they have included the in border point, they have included the mean points. It's less than or less than equals to. So that's depend on the author to author. So don't be confused about this. Just see this, the number of mean points is equals to 4, number on this region, number of point is also equals to 4. So now for these reasons, P2 is not a core point. First, the definition that we call P2 is not a core point. P2 is not a core point. Now P2 must be border point if it is lie on some neighborhood of some core point. Now what is core point here? P1 is core point. Now let's try to find the radius between them. I'm using the red color. Just see the red color, the radius between this. Okay, if you just find the radius, just see the radius value. Oh, here to here is epsilon, but the P2 and P1 are lies on these regions, not, so must be it is less than epsilon. This region must be less than epsilon. This distance must be less than epsilon, and because of these regions, it is as also a core point. Since the distance between P1 and P2 is less than epsilon, therefore we call P2 is a border point. Therefore we call P2 is a border point. Now let's try to understand the noise point here. Noise point, what it means, it's neither a core point nor a border point. Now I am using here different color, just deep blue color I have used here for this point, P3. This, try to understand the P3. For this P3, for this epsilon, this is the epsilon 1, and on this region, just see this region first. On these regions, how much point we have? 1, 2, 3. So on these regions, number of points equals to 3, which is less than the mean points. Which is equals to 4. Okay, mean points. So it is not a core point. First we got it. P3 is not a core point. Is not a core point. We understand these things now let's see why it is not a border point. So first try to find the distance between P1 or P2 to P3. So it is not we have to find the distance between core point to here, core point to distance from here to here. Since P1 is a core point, let's try to find the distances between P1 to P3. This must be greater than this distance. Distance between P1 and P3 must be greater than epsilon. Okay, must be greater than epsilon. Because of these regions, P3 is not a border point. Since distance between P1 and P3 is greater than epsilon, then we can conclude that P3 is not a border point. P3 is not a border point. I think you got the idea why, how these 3 points are defined. I think you got the idea. Okay, sure. Now let's try to understand this using these 3 concepts, how to apply on a real data. Using these simple 3 concepts, how you will apply these things on real data. This is the real data that I have taken from the Google image. Just see, this is our raw data. This is our raw data. Okay, by simple using these 3 concepts, core point, border point, and noise point, we'll easily separate our whole data into a whole cluster. Just see this thing. Just see this thing. The green one are the core points. Here the green color points are the core points. These points are the core points. Core points. Okay. And the blue color, see the blue color points. These points. These blue color points. These blue color points are the border point. These are the border point. And the red ones, red color points are the noisy point. These are the noise point. These are the noise points. I think you got the idea. By simple using these three simple concept, we can easily cluster. We can easily cluster this non-convex data set. We can easily these things. This is the beauty. This is the beauty of the mathematics. By using this simple technique, we can use how much accurately we can separate, how much accurately we can make the clusters of this non-convex data set. Okay, that thing in previous 2 chapters that we have already felt to separate this kind of structure. Okay, I think from the motto of this lecture, it has clear what is the concept of the core point, what is border point, what is noise point, and how we apply these 3 concepts in a real data. I think you got the sum idea. I request you, if you have any problem, although if you have any problem, please revisit this lecture again. Okay, sure. After that, if you have any problem, please mail me or comment below. If it is possible, then I reply it to the comment box. Either I will reply on it in your mail. Okay,